So in today's lesson, we're going to be learning about something called a characteristic physical property. So I just want to remind you that a physical property is a property that describes a substance sort of as it is on its own. And provide sort of a description that might help you identify it. So what is a characteristic physical property? So let's just read through this definition. It says it's a physical property that is unique to a substance and can be used to identify it. So not all physical properties are unique to that substance. For example, I could describe sugar as being a white crystalline solid, but I could also describe salt that way. So something like its color and the fact that it's crystalline may not be enough information for us to be able to identify a substance. So what makes a characteristic physical property characteristic is the fact that it is, in fact, unique to that particular substance. Think about it sort of like a fingerprint. So your fingerprint is unique to you, whereas your height is not unique to you. So your height would be a good physical description of you, but it would not be a characteristic physical description, whereas your fingerprint would be. So, for example, and I've listed a few common ones. So the boiling point of a substance can be a characteristic physical property. For example, we know that water boils at 100 degrees Celsius. So that if we had to identify whether a clear, colorless liquid was water or not, one characteristic that we could look for is the fact that it boils at 100 degrees. We could also use its melting point. So there would be very few substances in the universe that have both a boiling point of 100 degrees Celsius and a melting or freezing point of 0 degrees Celsius. So those are both characteristic of water. Density as well. So density is a great one, and that's actually going to be the focus of our conversation today. Density, basically, I think we have a good idea about what it is in principle and practical terms, but what we're going to look at today is, well, what does it mean if we're looking at it in quantitative terms using measurements? So water is at its greatest density at 4 degrees Celsius. So that means, that has meaning, and it would be useful for us to know that if we were trying, again, to identify a clear, colorless substance as water. So essentially, what is density? Well, density describes how much mass you have in a given amount of space, or per unit volume. So sometimes we can think of it, it's not exactly like this, but it may be useful for us to think of, well, how many particles can fit into a given amount of space. Now, that's not always the case, because some particles themselves are heavier than others. And remember that density is essentially about mass contained in a certain amount of volume. But nonetheless, it helps to give us a sort of a visual, conceptual understanding of density. So if these, for example, these green little particles here are the same as these green particles and everywhere in between, then we could say that in this case, there are fewer green particles in that amount of space, and that as we move along to the right, we continue to add a greater number of particles to the same amount of space. So essentially, we're adding more mass to the same amount of space. So in this case, we're looking at a circumstance where there's a high density of that material, whereas over here on the left, there's a much lower density. So there's our conceptual breakdown of density, but let's take a look at this from a quantitative perspective a little bit more. So I can tell you that the density of gold is 19.3 grams per centimeters cubed, right? So what does that mean? That means in every cubic centimeter, so let me draw that out for you roughly, right? So if I were to have a cubic centimeter, so imagine that this was a centimeter long, here's a centimeter wide, and so on, and then a centimeter back, right? So if I were to draw this, that's a centimeter cubed. And if this were gold, then I would know in that centimeter cubed that would weigh, if I put it on a scale, it would weigh exactly 19.3 grams if it were pure gold. And if it weren't pure gold, well, its mass might be heavier or lighter per cubic centimeter than 19.3. So that's the first part. Now the second part, here's a second example to help you consolidate this. Gold, we can say, is more dense than silver, not just sort of from a qualitative perspective, not just by kind of like guesstimating, but we know that because we can take the mass of a cubic centimeter of silver, and we find out that it weighs only 10.5 grams in that cubic centimeter. So again, like if I had gold over here, let me use a different color, or silver rather, and I had a cubic centimeter of it, it would, see, I'm not as fancy here, but I would know that it would not be gold, and I might be able to even identify it as silver because I would expect its mass to be 10.5 grams in that given amount of volume. So we're going to be doing a little bit of math today, as I mentioned. So let's take what we know about what density is and create a formula. Well, I know that density, remember, is the mass per unit volume, right? So if I have a certain volume here and I take a mass measurement of it, then I know that the density is going to be the mass of that substance divided, as a function of its volume. So that makes perfect sense given our formula here. Where density is the mass divided by the volume. So there are tables all over the internet describing the density of some common materials. You will find that in your textbook on page 193 that there exists a really short table. Now, in this particular table, we have, a lot of metals here, aluminum, zinc, iron, copper, but you can find the density on the internet for just about any substance. Somebody at somewhere has measured this. So, so make sure you find that. So maybe take a minute to locate this table in your textbook so that you have that handy, because you will need it in order to solve some of the problems that we're going to be looking at today. So people will say, well, if you're doing a calculation that involves measurement, you need to indicate the unit of measurement in your final answer. And so let's take a minute to talk about the units that we use for density. And I'm going to tell you that the long and short of it is that it depends. What does it depend on? It depends on the units that you used in your equation for mass and for volume. So for example, I'm just going to write out our density formula for a second. I know that density is equal to mass divided by volume. Well, let's say, for instance, that I put in grams for my mass, units of grams, and I put in units of milliliters for my volume. That gives me a gram per milliliter. But I could just as soon put in different units for mass and for volume, and that would give me a different unit for density. So, for example, I could also have included units instead of kilograms, and then instead of milliliters, maybe just liters, and that would give me units of kilograms per liter. And you will find that, right? So often solids, it's important to know that solids, instead of using milliliters tends to be a measurement of fluids. We'll use cubic centimeters for solids, and usually milliliters is the unit that we would use to measure the volume of a liquid. But it is important to know that 1 gram is equal. No, that is not right. 1 gram is not equal to a cubic centimeter. It's 1 milliliter. So let's just fix that. That should be 1 milliliter is equal to 1 cubic centimeter. There we go. All right, so we're going to do a little bit of rearranging. So we can see in this formula up here that density is equal to the mass divided by the volume. And that equation works fine as is if you were solving for density. But let's just say the problem that you're asked to solve gives you the density, but and gives you one of the other two variables, and you need to solve for the third variable. We need to be able to rearrange this equation. So let's do that. So if I want to write the equation, the density formula, and rearrange it in terms of mass, then let's start out with the basic equation here. Density is equal to mass divided by volume. So in this case, I want to get my mass all by itself. Then that means I need to get mass all by itself. So, and I need to get rid of the volume on the bottom. So a trick in algebra, in order to isolate a variable, is to say, well, I need to undo it. So in this formula on the right-hand side, I am needing to get mass by itself, and I'm dividing by volume. So to undo a division, I need to perform the opposite operation. The opposite operation to division is multiplication. So I'm going to multiply by volume. Whatever I do to one side, I do to the other. Now you'll remember from our unit conversions that if I have a volume on top and a volume on the bottom, then those will cancel. So that's gone. So now on the right-hand side, I have my m, my mass, all by itself, and I have v times d. So writing these letters out alphabetically, I have d times v is equal to m. Now this is my formula isolated relative to my mass. So all I would need to do would be to plug in the values that are given for density and for volume. All right, and we can also do a bit of a unit analysis. I'm going to do that. So if density, let's say, were measured in grams per milliliter, and volume were measured in milliliters, you can see that my milliliters will cancel and give me units of grams, and I know that mass is often measured in grams. There we go. Let's try doing the same thing for volume, and this is going to be a little bit trickier. So I'm going to write out my formula. Density is equal to mass divided by volume. So there are multiple ways you can go about this. I'm going to choose to show you this way, which is to cross multiply. Now we know that any number can be written as a fraction by simply putting it over 1. And now what I'm going to do is I'm going to cross multiply. So cross multiplying means taking the denominator of one fraction that's on one side of the equation and multiplying it by, and moving it up to the other side and multiplying. Then I do the same thing on the other side. So that will give me so far 1 times m will give me 1m, or just m, and then d times v will give me dv. Now I'm not quite where I want to be yet because I still need, in this case, to isolate v. V is what I'm looking to isolate. So that means that I need to get rid of my d. Now remember, in this case, I'm multiplying d by v. So in order to undo the multiplication, I do the opposite operation and I divide. So I'm going to divide out my d. Whatever I do to one side, I do to the other, and that allows me to cancel out my d's, and now I finally have v is equal to m divided by d, and I'm good to go. So I'm guessing that some of you may have been a little bit uncomfortable with the last process of isolating variables. So for those of you that are uncomfortable with math, I'm going to give you a bit of a trick. Okay, so this density triangle, you can see the variables that are there: density, mass, and volume. So if you can remember the density triangle, then you can rearrange the formula for density in terms of mass or volume, if those are your unknowns, in a very simple way. So, and many of you who are probably good at math may want to use this as well. So this is essentially how it works. So you would take the variable that it is that you're looking for, and you would simply sort of cover it up. So I'm just going to pretend that I'm covering up d. Okay, so the variable that I'm looking for, I'm going to write down d equals, and I'm going to cover up that variable. And what's left over tells me how the formula needs to be arranged. So I'm going to think of this little line right here as like the dividing sign, okay, like on a fraction. right there. And this is telling me that m has to go on top of the fraction and v has to go on the bottom of the fraction. Let's try that again. Instead, though, with the other variable. So I'm going to do this in blue now. So let's say, for instance, the variable that I was looking to solve for was m. So the question was asking me for the mass. I'm going to hide the mass, cover it up on my density triangle, and I'm going to write that out. M is equal to. Now in this case, you can see that the d and the v are beside each other, and that implies that they're being multiplied. So m is equal to d times v. Done. Now let's try that again with my volume. Why don't you try it on your own, pause the video, and see if you can get the right formula for volume and using the density triangle, and we'll see how you do with that, just to kind of gauge your own understanding. So now I'm going to do the rearranging, or if I had to solve for volume. So for volume, I'm going to hide that variable with my finger or whatever. I'm just going to scratch it out here and put v equals. So the way that the other variables are arranged tells me how the formula needs to be arranged. Since m is on top of d, that means I'm dividing m by d, and now I've got my formulas organized. So I hope that helps those of you that were struggling with rearranging those formulas. The density triangle is a really useful tool to help you rearrange those formulas. Because of course this is a science class, not a math class, and so that may help you get to just make it easier for you to problem solve. So take a couple of minutes here to copy down this question. The example says 25 gram sample of an unknown metal occupies a volume of 3.2 centimeters cubed. Identify the metal. So I want you guys, when you're first problem solving in this class, to have sort of a method to use to frame it out so that you can kind of break it down into manageable chunks. So what I'm going to teach you is something called the grasp method, or the GRASS method. So I've hidden it underneath here, but I'm going to now sort of undo it. So each of those letters in the word grass stands for something. So G-R-A-S-S. So in this method, the G stands for given. And so what that means is that you're going to write out any information, any numbers, any measurements that are given in the problem. So I'm going to go ahead and read my question, highlighting anything that is numerical to help me figure out things. So 25 grams. So grams is a unit that I use to measure mass. And so I know that I'm given the mass. I know that I'm given the mass in this question of 25 grams. So I'm going to write that out. I also, as I read through this, notice that I am also given that the volume is 3.2 cubic centimeters. So I'm also going to include that in my givens. So V is equal to 3.2 centimeters cubed. There we go. All right, so next is required. So required to find. What in this question am I asked to find? Well, usually I say look at the last section of the question in order to figure out what's being asked. And here they're saying identify the metal. Well, the characteristic physical property that's going to help me to identify the substance, the metal that I have, is density. So my unknown in this case is density. So I'm going to write out D equals and then question mark. That is what I'm looking for. And I'm going to use the chart on page 193 with the density value to help me pinpoint exactly which metal it is that I'm looking for. So the A in my GRASS method stands for analysis. So the analysis is essentially me just writing down the formula that I'm going to use in order to solve And so if I use my density triangle, I'm going to write that over. So unfortunately, I realized that I had been recording myself without having pressed, I was going through the question without having pressed record. So I'm going to give this another try. So here is my example. A 25-gram sample of an unknown metal occupies a volume of 3.2 cubic centimeters. Identify the metal. All right, so in order to keep things nice and organized, when we're problem solving, you can choose to use something called the GRASS formula. So each of the letters in GRASS stands for an element of the word problem that will help you organize and manage some of the smaller tasks, and that will allow you to get to solve the problem in a more sort of chunked way. All right, so I'm going to give you a minute. You should write down this question. And let's break this down. So the G in the GRASS formula stands for a given. So in this case, what you're going to do is you're going to look and see, well, what measurements, what information am I given in this problem that can help me solve it? So I'm looking for some numbers because I know that this is going to be a word problem where I'm going to do a calculation. So 25 grams, that is a unit of mass. So I'm going to write that my mass, I'm going to write that my mass is 25 grams. Now, another piece of information that I'm given is that the volume is 3.2 cubic centimeters. So I'm going to go and write that down as well. V is equal to 3.2 cubic centimeters. So now the A in the R rather, in the GRASS method stands for required, or required to find. So now is where I'm going to write out, well, what information am I looking for? What is the unknown in this circumstance? And so usually I find that in the last paragraph, or the last sentence rather. Okay, identify the metal. So then you say to yourself, well, what in incarnation is going to help me solve for what the metal is? And I'm going to remember that density is a characteristic physical property. And so if I can use mass and volume to get the density, I can use my chart on page 193 to help me solve for the metal. So the density is my unknown, so I'm going to write out D equals and then question mark. All right, next. So the next component of my problem solving is the A in the GRASS method, and that stands for analysis or analyze. This is where I'm going to write out my formula, the formula that I need in the right way. So let's write out our density triangle here. So I know that density is equal to mass, divided by volume. And so by looking at my triangle, I know that I can write out my formula. Covering up D, I have M divided by V, and there it is. In the next section of the GRASS method is this second S here. And so the second S stands for solution or solve. This is where I'm going to substitute or plug in the information that I have into my question in order to solve for my unknown. So my mass of 25 grams and my volume of 3.2 cubic centimeters. And so solving for that, I'm getting 7.8 as my value. And I'm also going to say, well, what unit should I be using? I divided grams by centimeters by cubic centimeters. And so that tells me that the units in question are grams per cubic centimeter. Now, I don't know necessarily what that is. So, I don't know what that value represents. So, I'm going to go ahead. I'm going to look at my chart on page 193. Let me see if I can move this up. Let's see. I'm going back to my chart, and it says 7.8. Well, this is science, right? And not all of our numbers and measurements are going to be perfect all the time, but I can see squarely that iron has the value that is closest to the value that I obtained. So I'm going to go ahead and make the decision to say that, in fact, our unknown metal happens to be iron. So now is where I need to finalize my question by giving a statement, and that is the final S in my GRASS method. So I'm going to make a therefore statement. I'm not sure if you guys are aware, but in math we can use the symbol, this little symbol with 3 dots, like that. And that is considered to be a short form for therefore. So I'm going to write therefore the metal with a density of 7.8 grams per cubic centimeter is iron. So there, now I've completed my word problem and my format is perfect. All right, so here is a second example. I guess it's a third example. What would be the mass of a 12.5 cubic centimeter piece of lead? All right, so what I'd like you to do is I'd like you to pause the video, write this question down, and then attempt it on your own. And when you feel that you've given it a good attempt, or if you're stuck, then resume the video and watch my solution. All right, so I'm going to go ahead and solve this. So the question says, what would be the mass of a 12.5 cubic centimeter piece of lead? All right, doesn't seem like they're giving me a lot of information here. I can tell definitely that they're giving me 12.5 cubic centimeters. That is a unit of volume. Oops. So I am going to write that out. So V is equal to 12.5 cubic centimeters. And, what am I required to find? Well, they're asking me for mass, and so I know that my required to find in this case is my mass. Now I'm going to think about my density triangle. I'm going to write that over here. I know that density is equal to mass divided by volume. But in this case, I am asked to find the mass. So in order to do that, I need to have the volume, but I also need to have the density. The question does not give me the density. So how am I going to figure that out? Well, one thing that I noticed is that they told me that it was lead. And so now I need to go back. I need to go all the way back to my chart and see that in this case, it's telling me that my lead has a density, is that right, of 11.36. So I'm going to remember that number, 11.36 grams per cubic centimeter, and I'm going to go all the way back, 11.38, 11.38, 11.38. And I'm going to include that over here. So my density is equal to 11.38, and the units in the chart that I'm using are grams per cubic centimeter, so I'm not going to forget to include my units. So now I'm down to the analyze or analysis portion of my solving. So if I hide the mass, let's hide that, then I can see that the formula that I get is D beside V, which tells me that it's dV. So M is equal to dV. I'm going to analyze that now. I'm going to solve my question now. So M is equal to, my density was 11.38 grams per cubic centimeter, multiplied with my volume of 12.5 cubic centimeters. And if I look at this carefully, I can see that my cubic centimeters are going to cancel, and my grams are what I'm going to be left with. So I know right off the bat that my units are going to be grams. Let's work out this multiplication. 11.38 times 12.5. I'm going to round that to the nearest whole. The nearest whole gives me 142 grams. So now I can go ahead and write my therefore statement. Therefore, the lead has a mass of 142 grams. All right, take a minute to write out this next question, example number 4. So pause the video and resume when you're ready. I'd like you to also try the question, and then we'll take it up together. All right, so let's take a look at what's given in this problem. It says predict the volume. So that right away is my unknown. I'm going to go ahead and skip my G for now because I see that the volume is what I don't know. So oops, keep doing that. So I'm going to write out V is equal to question mark. That is my unknown. There we go. Now I'm going to go back and say, well, what else am I given? I'm told that it's 150 grams. So grams are a unit of mass. So I'm given my mass of 150 grams. And it tells me also that I'm working with gold. So I'm going to need to do some backtracking here. So I'm going to go back all the way back, skimming through. And I'm going to see that gold has a density of 19.32 grams per cubic centimeter. 19.32. So I'm going to write that out. My density is 19.32 grams per cubic centimeter. So let's analyze this. I'm going to write out my density triangle. Density is mass divided by volume. And so if I analyze this, I'm solving for volume, so I'm going to kind of hide it. And I can see that my mass is divided by my density. So the formula written correctly is volume is equal to mass divided by density. And my solving now just involves plugging those values in. So mass of 150 divided by my density of 19.32. Let's write in some units there, grams, and then grams per cubic centimeter. And when I solve for that, I'm a little bit, I'm going into my S space here, but I'll leave room for that at the end. Then I divide my 150 by 19.32. And I'm getting, if I round that to the nearest decimal, I'm getting 7.76, yada yada. So I'm going to round that to 7.8. And since I used grams for my mass and grams per cubic centimeter for my density, the unit that I have for my volume is going to be cubic centimeters, so I need to include that in. Now I'm ready to write a statement about this. So therefore, the volume of the gold is 7.8 cubic centimeters, which is probably worth a lot of money. All right, hopefully that went okay for you. Let's try one last example. All right, so this is our last example. It says calculate the density of a 5.8 gram sample that is 22 centimeters long, 13 centimeters wide, and 4 centimeters high. All right, so I would like you to write this down and to think about what strategies you might use in order to find the solution to this problem. It involves 2 steps rather than 1. So use your knowledge from math class and geometry, I guess, area and measurement to help you figure out how to solve this. When you're ready, resume and we'll take it up together. All right, so in this case, let's look at what information I have. I'm asked to calculate the density I'm given that I have a 58-gram sample. Okay, so let's write out some of that. So I have my mass in this case, and it is 58 grams. And I have that my density I'm required to find. But what other information do I have? Well, I have the fact that it is 22 centimeters long. I have a length, I have a width, and I have a height. So let's write that down. I have that I have my length is 22 centimeters. I have a width of 13 centimeters. And I have that my height is 4 centimeters. So remember that my density triangle, I'm going to do that over here, involves me knowing my mass, my density, and my volume. 2 out of these 3 things. And right now, I have my mass, that I have, and I'm looking for my density, but I don't have my volume. So that's a problem. So I'm going to hope that you remember that from grade, I don't know, I'm not sure, maybe grade 4 or 5, something like that, that volume can be calculated if you know the length times the width times the height. So that's sort of like a little sidebar project that we're going to need to do here. So I'm going to do that in red so it's a little bit more evident. So I'm going to say 22 times, let me write in my units there, 22 centimeters times 13 centimeters times 4 centimeters. And you'll notice here I have centimeters times centimeters times centimeters, and that will give me my cubic centimeters. Now I'm going to multiply these values through. Let's do that. So 22 times 13 times 4 will give me 1,144 cubic centimeters. So now I'm ready. Now that this is now something that I know as one of my, it's not given, but I've problem solved that. So I'm ready to go back to the original, solving the original problem, which is my density question. So I'm going to write out my formula by hiding my density in my density triangle and remembering that density is equal to mass divided by volume. Now I know what my volume is, and I knew what my mass was because they gave that to me. So 58 grams divided by 1,144 cubic centimeters. And so working that out, I'm going to do that over here. Density is equal to 58 divided by 1,144. And that gives me, and I'm going to round that to the third decimal place. I'm getting 0.0506 blah blah blah. I'm going to write that as 0.051. I don't know why I paused. Grams divided by centimeters cubed is grams per cubic centimeter, and I'm done. So therefore, the sample has a density of 0.051 grams per cubic centimeter. So in Google Classroom, you will find a worksheet that you can work on after tomorrow's quiz. If you want to get a head start on that, you can certainly work on that tonight for homework. And if you have any questions, then use your colleagues to help you work through these questions and make sure that you're checking the answer key to see that your solutions are correct.